This is building an electric motor lab. To start, the goal of the experiment was to create a model that explains how changing the current or magnetic field affects the speed of the motor. We saw that the speed of the motor increased as the current was increased, which was a result of increasing the number of batteries that we placed into our circuit. For our models, we have some wire and magnets and batteries, and we're looking at electric forces and magnetic forces between them. For our experimental design, we have this wood block, and we have these arrows are these two metal wire stands that hold a metal loop that's placed on top in the red. We also have Play-Doh that secures magnets to the wood block so it doesn't move, as well as electrical wires attached to batteries that helps make the circuit what it is. But in our model, only one side of the metal wire was stripped because it's normally insulated. If both sides of the wire were stripped, the wire would get stuck where the attraction to the magnets was the strongest, so it would just oscillate in that position. The left side, the golden color, means that we stripped the entire way around on one side of the wire, and the other side we only stripped one half so that it could act as a switch and let current flow or not flow through the circuit. With only one side of the wires stripped, the attraction site wouldn't be as strong to stop the wire from moving, and the wire would continue to spin. Some of our equations we use is V equals Ki omega and V equals IR, relating current, speed of the motor, resistance, and voltage. And from these equations, as voltage is increased by increasing the number of batteries in our case, the current was also increased, and this was assuming resistance was held constant. Also, motors with an increased voltage will have an increased speed, which was the case in our experiment. Just to prove that adding more batteries increased the voltage and current, we have measurements from ammeters and voltmeters, multimeters and stuff like that, and as we increase the number of batteries, the current and voltage did increase. Also, we used the tracking software to track the velocity of the wire as it rotated, and we showed that as the number of batteries increased, the velocity did increase as well, so it did have an effect. Note that battery number 3 isn't in here. That's because the video seemed to be corrupted. So sources of error is improper sanding of the metal loop wire. That can have some funky things with the current. Uneven height of the metal support stand rings, which causes the wire to lean and be uneven physical proximity to the magnet below it. Friction and resistive forces, which we have in all of our labs. And the batteries could have been partially drained, which could affect our actual numbers with proportional changes in velocity. To conclude, we have demonstrated that adding more voltage batteries to our circuit will increase the current, and this current increase directly increases the speed of the motor, causing the motor to spin faster. Thank you.